So first here we have Kostis Sagonas. He worked on Hype and Dialyzer, some of the first things, and then he's been working on testing tools, Proper, Conqueror, Qt. Yeah, it doesn't get any better than that, does it? With those names.
Well, you cannot get cuter than that,
Yeah.
but you can find other names.
Yeah, sure.
So, for example, I have a new name that I will not announce, but it's cool.
Ooh, building up suspense. Lovely. And then we have Kevin Hammond. There, you put monads into Haskell.
Yes.
Yeah. Yeah, so we have that. And you also wrote the first Haskell compiler, and then you worked with parallelism for Erlang, and
Yes.
now you're into taming robots with type systems.
Yes, amongst other things.
Amongst other things.
Amongst other things,
yeah.
Amongst
So
other things.
you had a
We'll discuss that.
Yeah, but you had a good talk earlier today there. And then Natalia Chechina. Yes, I still remember that. You've been into the scalable distribution of Erlang, and now you're into collaborative robots.
Yep.
Oh,
that's right.
Interesting. And Simon, you've been into you've been to functional programming for ages. That's your own words. So you started out with Haskell.
Miranda,
and then
no, KRC.
KRC, yeah.
And
then you did some Haskell. You even did a book.
I did.
And then you realized that types are bad, and you went to Erlang.
I did. That's right. But then I did the 3rd edition of my Haskell book.
Okay, so you came back.
That's
so
right.
I'd like for you, if you'd start out just briefly, tell us about your first encounter and why the first thing you did research-wise with Erlang. Just briefly, so we get an idea of where you started. Who wants to go first? Shall we say ladies first?
Okay, yeah, I can do that. So I started with Erlang when I started working on the release project, and it was quite interesting because I'm interested in distributed systems, and the first rule of distributed systems is don't. But with Erlang, it was so bright, so colorful, so exciting, so really fell in love with the language.
Yeah, we've all heard that, falling in love with the language.
Yeah.
We all love that. So, and Simon, where did you start?
I guess I think I learned about Erlang when it was first around. I think I have a tape somewhere of an Erlang that we bought before it was open source.
Ooh.
I don't think it still plays, but we can download it other ways. So I looked into it and was intrigued, but didn't do a huge amount with it. And I suppose it was mid-2000s that I got interested in looking. We'd done some work on looking at refactoring Haskell programs, seeing how you might support that with a tool, and then got intrigued about how different things were in Erlang. And I think it was quite exciting, the fact that there was a strong user community around Erlang. I mean, Haskell has changed. The Haskell community has changed hugely. In the early 2000s, it was a bit inward-looking. I would have to say, whereas Erlang was a much more engaged community, much more interested in how Erlang was going to be used in practice, and also just it's a very different language to work with. Haskell is big, quite controlling. Erlang lets you do things very easily, much more freewheeling.
True. And Kostis, was it the Hype?
So I think that very few people know this story, so I'll share it with you. My first encounter with Erlang was actually when... so my first love actually in programming languages was Prolog. So I have been working on Prolog virtual machines for quite a while. And my first encounter with Erlang was actually a talk I heard by Dan Salin, who is sitting there. I think it was in Japan or in Berlin or somewhere in a logic programming conference. And my first impression was, oh my God, Prolog is so nice. Why are they doing that? So little did I know at that point that I would get a position in Uppsala University just 2 months actually after Erlang became open source. And I would meet a wonderful set of students who have been working on something called the Hype compiler. And I would say, this is what I want to spend a considerable amount of my time working with these talented people and contributing in the way that I can. And it was downhill after that, you know.
For some definition of downhill. Actually, now you bring up your reaction to seeing Erlang the first time. When I saw Erlang the first time, I looked and I said, no types, asynchronous message passing, and what's that syntax? And then I ditched it for a couple of years and went back to it. So we all get older and wiser, I guess. So, and Kevin?
So I was thinking, I first came across Erlang when I was doing my PhD. I can't remember quite how long ago that was, Torben, but it was a few years ago.
Yeah, we will not.
Don't
go into that.
I'm sure we could Google.
We can Google it.
You can Google. So we knew a lot about the community was quite small at that time, and everyone was in touch. But I do remember being on a boat in Amsterdam with Joe, and Joe saying to me, "You really ought to sign this petition to open source Erlang." And I thought, what the heck is Joe up to? He's up to something. I don't know what he's up to, but he's definitely up to something. But I signed your petition, Joe, so please send me your royalty check later. But the first time we worked seriously with Erlang was on the Paraphrase project with you, Torben, and with Francesco, with people from Budapest, Elta from Budapest, and people from AGH, which was about refactoring parallel programs. And Haskell, I think, is probably my first love, but Erlang does have some nice features. And
you do need a mistress, right?
Wow, could I say that?
No, I'm Danish, so I'm allowed
You're
to say
Danish.
those.
I'm British.
British
do
people
this.
can't say those
We don't do
things
this.
because yeah. So anyway, so all of these people that work with me, and I'm clearly not a researcher there, but you collaborated with me through Erlang Solutions because we're the industry. And this is also something we'd like to bring up, and I'd like to hear from you some examples of good collaboration between the research side and the industry side, because I think for a lot of you out there, it's difficult to envision how can I approach these super intelligent people and make something meaningful with them. But there are ways to do that. Who would like to tell about a successful encounter? We don't take all the bad ones with me, so just leave that out and pick a good example.
Yeah, so one of the recent ones we've been doing, this is not from the Erlang community. So we have been working with a static analysis company on an EU project. They are very heavily involved in the automotive industry. And with us, they have come up with a new standard for automotive software for multi-core systems. And that's being accepted by various large bits of industry. In fact, they've been so successful, they've managed to sell themselves to a large company, been acquired by a large
And what makes that collaboration successful?
Well, I think like all collaborations, it's the people, Torben. You have to have good people, right, on the project. And you have to be working with people who are enthusiastic about the work that you're doing. They have to be inspired by that. And of course, you want people to ask you questions. So people who say to me, well, why did you do that? Often causes me to question why I did that particular thing. Something that's obvious to me, I've been doing it for 20, 30 years, often isn't so obvious. And when you work out why is someone asking that question, that can lead you to some very interesting answers.
Yeah.
But it's also people who set challenges that go beyond what we can currently do. So I'm particularly enthusiastic about tackling new things, about looking at the major problems of the world. So anyone who's got a major problem that I can have a chance of solving, yes, I'm very happy to chat to you. And if not, I know somebody who can.
So, what about you, Kostis?
So I've been heavily involved in the Erlang development from the time I joined Uppsala University. So obviously,
So we're talking the OTP team collaboration.
so obviously we have had a very good and fruitful collaboration with the OTP team at Ericsson over a number of years. And I think that one of the successes of my research is that some of these tools have ended up in the Erlang OTP distribution and have affected the lives of not just the Erlang community, obviously, but these days also the Elixir community. It's also interesting to see that some of the tools that even have not made it into the Erlang OTP distribution for whatever reason, they are being considered to be used by the community out there and or being reinvented in a way or another. For example, this morning I heard about the Elixir community trying to do a check spec thingy for that Proper has for a number of years now. We did it over a weekend. No, it's true.
Yeah, and I personally, I love the way when you run Dialyzer, the way it just slaps you in the face over and over again, and it never gets tired. It keeps slapping you in the face, or maybe it's just me. I don't know.
Try the Haskell type system.
Yeah.
You'll love it.
I tried that recently, and it's
Yeah, the difference is that when Dialyzer slaps you in the face, it's right.
No, yeah, exactly. The Haskell type system just slaps you on principle.
Yeah.
That's true. That's true. Quite true. So, Natalia, good relationship, good collaboration with industry?
Oh, well, I didn't have much experience yet to do that, but I think from my experience, it was about when, industry and academia just complete each other. Something that, like industry, the company I did my internship in, they didn't have time to do the proper analysis of the system and didn't have sufficient expertise there. And that was me. I love to do that. And I suppose, when I had the opportunity and expertise to do that, and I had the real problem, that was the perfect match. It was really exciting, I think. And we still keep in touch, although it was quite a while ago.
Oh, that's good. That's good. It's always nice that they don't forget you the minute you walk out the door.
Yeah.
So Simon, and
I was thinking, I mean, I've done a lot with Erlang Solutions and Francesco, but I was thinking, how did that start? And it was Francesco being aware that the thing to do was to build a relationship with a university. So he said, I'll come and do talks to your students. And Torben has done the same. And I think I'd encourage everybody in the room, go to your local university or go to a university where you have a contact already and say, can I come and talk to your students? Can I come and talk to your grad students? Can I come and talk to your colleagues? Because that's a way you start having a conversation. And when you know somebody, they become the person you go to. I'm sure that's true with Kostis. He knows the OTP team very well, so they go to him. He's their go-to person. So I think I would encourage you to just to build those relationships. If you can go in and talk about how you use Erlang, there'll be people academics will love you to come in and talk to their students. It's the audience we get for Torben. I mean, and he does his offensive programming, and they love it, because it's very. He's somebody who's talking with authority, whereas we're academics. What do we know? So that's a really good start, and often the really important relationships you finish up having are ones which start like that. I mean, the other thing, I've been doing some work with a company who are doing some blockchain development. And the reason they came to talk to me was I wrote a book years ago about constructive type theory, and their CEO had read that and said, oh, let's talk to Simon Thompson. He seems an interesting guy. Let's talk to him. So, these things can come from very small beginnings, but they can grow into something where you've had that conversation. You can focus on important things. So I encourage you to do that. And people, they will bite your hand off, probably.
yes, and I've been down talking to your students a number of times, and it is a good thing. And you don't have to be the world's most articulate person to do it. Just go in there, explain about what you do in industry and the kind of pains you experience, and they will look at it and go, interesting, because that's not what they're being taught by the professors, for good reasons. You shouldn't tell them, when you go to industry, it'll be all pain and look gleam and everything. So, So this has been a bit, we get a little of the background and some of the reasons for things turning out to be successes. And then I'm going to challenge you a bit on if we fast forward 10 years, what would you like to have your name on of contributions to the Erlang ecosystem or the Beam world? What will you do to become a gold star Beamster in 10 years' time? And then we might need help from the audience. Say you should look at this. I don't know if you have some ideas, but what would you like to have your name on? Oh,
That's a good question.
I suggest everything, Torben.
Everything. Okay, that's a modest claim.
Well, you said like.
Yeah. So you want to be named Kaiser? Okay, fair enough.
So the thing that's intriguing me at the moment, the thing I'm mostly spending my time on, is thinking about first-class properties of systems. And this isn't Erlang specific, but balancing security, safety, reliability, energy, time, multi-core, all in one package. That's what I think is really interesting. If I can make a contribution there, that's what I would like to be known for.
Mm. That's like almost everything.
Almost everything. Making software an engineering profession, or helping make it an engineering profession.
Well, it's this 50th anniversary since the software crisis, isn't it? There's a conference going on in Gothenburg where they're celebrating. There was a NATO conference in 1968 where they invented the phrase software engineering. So the first 50 years haven't been terribly auspicious, I guess, in many ways. But hey, next 50 might be better.
Might be better, or we just continue to run into problems.
We have got UML, so
yeah,
we should be happy about some things.
It's a cancer that spreads, and it's hard to kill. So yes, you're through there. So, Kostis.
So, I'm not sure. I don't have, although I'm in academia, I don't have such long-term plans of what I will do in the 10 years. I'm only looking at things I will do in the next 2 years.
Like the tools for the name we don't know.
Yeah. But what I would like to see is a bit the community going towards a direction where the tools are used more. I think we have a lot to learn from the Elixir community. I might have my opinions on Elixir, but the community is very, very nice. The way they are doing their tooling business is something that the Erlang language should learn from. For example, we did this work on Dialyzer, and it's in OTP. I still don't understand really why nobody from the OTP team or from the Erlang user community has not contributed something that runs Dialyzer automatically every time you make your system. Perhaps people are afraid that they will slap it in the face, but that's not a good excuse, really. So
no, it isn't. You're right.
So also for other tools, I think Erlang should not be left behind times. So I think tooling is something that the community should invest more. And things should be automated. We have, in this day and age, computers that have multiple cores. And these cores can be,
put to use.
This is obviously not a 10-year plan. It's actually very sad if it's a 10-year plan.
That would kill Erlang, actually. You're right on that one.
I don't think the community should wait 10 years for these things to happen.
No. Natalia.
Oh, right.
I'm not forgetting you.
Yeah, no, it's fine. Actually, for me, that would be introducing ethics of Erlang into cooperative robotics. So what I'd love to have in like 10 years is that we have thousands of complex but fault-tolerant robots that can work cooperatively. And if we can have this, and if I can have like contribution to that, I think that would be really, really exciting.
Terminator. Okay. More or less. So.
Yeah, it's difficult. I mean, 5 years, it would be very nice to see the equivalent of Dialyzer, but for sessions, but for communication. Something that will, I mean, I have a PhD student who's working on the beginnings of this. How can you write lightweight annotations to your Erlang program, which express the intuition you have in your head when you're writing it, and can then be checked about how things should communicate and so on. And doing the completely general tool is difficult because Erlang, the joy of a lot of things we're talking about, the joy of Erlang is that it's small and it's freewheeling and so on. But that's what makes typing so difficult. And I think what Kostis is saying about Dialyzer is a hard one, because I think one of the things you get from something like Haskell is you can do type-driven programming. You can write a type. The first thing you do is write the type and then construct the program piecemeal. And because of the way the system is built, and that's been built in from the start, you can do that easily. You can't do concurrent programming in Haskell easily because it's a library and there's all sorts of other cruft around it. Erlang turns that on its head. Concurrency is there, but type-driven development is just not made as easy. It's possible, but it's not so natural. So I'm not, I think there are horses for courses, and I think one of the nice things, interesting things about Elixir, programming language work seems to go in phases. In the 80s, everybody had their own functional programming language. If you wanted a language, and then Haskell came along with the explicit intention of becoming a platform for doing research. And so I think people's own languages died. But I think Elixir shows that sometimes having a new language is an impetus for doing new things. So, and Haskell has maybe got too big, and other things will replace it in other areas. So I think it would be very nice. So perhaps Erlang as a language stays where it is, but the ideas of Erlang going into lots of other places would be fantastic. To see communication-based concurrency being the norm and not the exception. And that's so in a sense that would be my long-term aim, is to see multi-threading disappear and to see a different sort of concurrency take the fore. It might be the sort of concurrency you see in Erlang, it might be channel-based, but to see that getting to the forefront of people's toolkit for building concurrent systems. I'm not sure my research is, and maybe building the right sorts of tools will help with that. Stop me spilling money out of my pocket. Yeah. So yeah, maybe that's not.
No, but tooling would definitely help, because as I often have in all my slide decks is these message sequence charts, which relates back to how is this thing supposed to play with other things on a grander scheme. Yeah. And it's actually a little bit annoying that you have to go and write that after the fact or before as a design, because I always design it up front for these things. But it would be nice to be able to suck it out of the code somehow.
Exactly.
There. That's why I like a thing like your Conqueror thing will suck out concurrency errors without having anything extra in. So that's actually a neat thing. But sometimes you need something extra. And we'll not go into the slapping in your face with Dialyzer now, but that's also quite good for some situations there. So let me see, how are we doing on time?
So we hear the beer crates clanking.
Yeah, no. There'll be plenty of beer on wherever we're going, because we're going somewhere. Kevin, you had this endeavor into parallelism with Erlang there. Where's that at the moment? Where have you taken that? Because that was like a different way of approaching, because Erlang is concurrency and you come along with parallelism, and how do we do that?
Yes, it worked out quite well in terms of the technical focus. We were able to get some very good results by exploiting the Erlang concurrency mechanism, then by building on top of that. In fact, I've got a video of Joe in an office in St Andrews a couple of years back, trying our tool and saying, wow, I just did this and it works. So by using the refactoring tool, he was instantly able to parallelize a program and get it working, and that was great. We haven't done very much with that recently, unfortunately, though one of my postdocs, he does keep going back to it. But I'm very much interested, A, in releasing what we did there and getting people to use it, and B, in developing abstractions that cover Erlang and other programming languages to do essentially these things. So that's what I'm looking at.
Yeah, because that was all about generic patterns.
It was about generic software patterns.
Yeah.
So we're at the stage where I think we're getting things that are pretty well generic, language independent, but they're not as widely known as they should be yet. Yeah. It's a real technical problem to get that stuff.
So because then I can throw in my personal request here for Simon, Wrangler for Elixir, please.
That would be nice. Yes, if people would like to collaborate on that, that would be fantastic. Yes.
Yeah. So what do you need for that kind of collaboration?
People.
People. Oh.
Come and talk to me. No, that would be interesting. Yes. I have thought about it, and I had a student who did some initial work on that, and it was nice playing with the macro language, because you do get a lot more. You get some leverage from that.
Yeah, that's that's not so bad. So,
but that would be fun.
Do we have questions from Joe?
Just.
I wonder about protocols. I mean, the protocols are there, but they're not. A protocol is not a first-class object. We don't declare them.
Well, that was what I was hinting at. Yes, exactly.
So I'd like to see work on session types and things like that, where we explicitly sort of tie down those protocols. Because I don't really, I see programs with black boxes talking to each other, and I think we're looking inside the black boxes too much and not looking at the wiring between them and how they're connected together. And in particular, I'm interested in why things don't work. I mean, at home I have a Sonos device connected to a router, connected to that, connected to Spotify, and it works fine hour after hour after hour, and then suddenly it just stops. And nobody on the planet knows why. So really, if we were looking at all these protocols, we should be able to apportion blame. So I don't know, whose fault is it when something goes wrong? Why do things just stop?
They're implementing just let it fail, I think.
But I like to. But I don't.
And you've got to switch it off.
But I don't know who to blame. I mean, the state of the art of computer.
Indeed, that's true.
Telling my neighbours, just reboot it doesn't seem very satisfactory as a result of 50 years of computer science.
You're the supervisor, I guess. You switch it off and switch it on again, and that's it.
But when are you going to start describing sessions? And
I think
protocols?
But I think that's
first-class objects.
But I think, and this is for me where working with people who are solving practical problems is so interesting, because there are people who've done all the interesting theory on how session types are really like linear logic and blah, 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 which is lovely and difficult and intellectually very, very elegant. But Erlang isn't like that. So the question is, how do you take those ideas and make them into a tool that's useful for real Erlang programs? Or maybe real OTP programs. So, and Erlang's talking to other things, yeah. And distributed Erlang, and how much, I'd be interested in what people's views are. Is there research to be done in how Erlang distribution works, or how it might work, and so on. So I think but it would be interesting to hear what people have to say in general.
I have a question myself. What is the biggest challenge you see to adoption of some of the research results you've seen? Maybe pick a specific example.
Bad cop, good cop. So
I just thinking about the question. The biggest challenge is usually a closed mind. So there are people who you go to and they refuse to listen to facts. So there are people who are completely unconvincible, and there's no point arguing with such a person, because no matter what you say to them, they will always be unconvinced, And if they're in a position of authority, they will then be able to stop the research from being adopted. So you have to go to people with open minds, Francesca. And of course, it's the other big obstacle is it won't work, right? It's the easiest thing in the world for someone to come to me and say, oh, what you're doing there, it's not going to work because it doesn't scale, or you haven't implemented this particular feature that is absolutely essential for my system, etc., etc. And of course, research results are not going to work in all situations immediately. The research results, they're like babies. You've brought them up, and they are just about able to crawl. But the fact that they're not walking, talking, and engaging in intelligent conversations is not really a problem yet. Give it a few years, and yes, it becomes a problem. So I think those are the biggest obstacles that we have, rather than technical ones.
Yeah, I think I would. Sorry.
No, I would just agree with Kevin, because I think very often after completing a project, we stop at prototyping level, right? Whereas the company, to adapt a technology, they need something much more developed, something much more polished, tested. So I think, maybe introducing, like now we have this impact accelerating project and things like that, maybe tailoring them after the projects to enable, this a little bit of time to polish the code.
Yeah, so Natalia is raising an issue, which is how do you go from the research result, which is small and not usable, to something that people can actually use, and that's quite a hard step too, and it's also an incredibly expensive step, quite often. We think when we've got the research result, we're done. That's maybe 10% of the work.
Yeah, so Simon, you started with things on Wrangler. How long did it take before it actually?
Well, we had funding for that initially,
yeah.
But I was thinking about this during the keynote this morning. I mean, open source is in a sense the key there. That what you hope to do is you build something that has got enough in it for people outside to want to buy in. So we're hugely grateful to people who've contributed, particularly Richard Carlson, who put a lot of effort into making Wrangler work for in the Klarna setup. And that's, I think, as universities, we can't necessarily do all the engineering that takes you from the research result to we can do some. But so I think we've got to try and focus what we do on solving problems that are going to be, that people want solving. But I think open source can be, I don't want to overhype it, but it can be that mechanism. And I think it's very affirming if people do put effort into things that you've done. So open source is a very nice way of putting your child out there, and other people take over their upbringing. Yeah.
So coming back to what Kostis says about tooling in Elixir world, and then if I look back at the different research projects, I mean, did we in some way in those projects fail to actually wrap it up the way it ought to be to enhance adoption? Well, now I'm the bad cop, but I was in it, so I'm allowed to. Is that something we because
but listen to what Jane was saying. Yeah. If you were in Jane's discussion this morning,
unfortunately
she was talking about what it's like being in a startup and saying it's a roller coaster. So in some ways, doing research, it's a more cosseted environment. You've got a salary, but it's making sure that research you do meets needs that you expect. It's not. It isn't a linear thing.
Definitely not.
So I think there are similarities there, and you might get some of the way, and things get. I mean, I can see tools that Erlang Solutions are now selling. The initial ideas for those were in a project, and they've put more effort into them, and they've gone into being a successful project, successful product. So I think you win some and you lose some, but that's the way of the world, isn't it?
Yeah, it is. But I'm just reflecting on being grilled in front of EU bureaucrats at the final review and says, "Where's the impact on industry?" And maybe there's something about, if not doing it, but at least have a more concrete plan about how to wrap it up at the end or come up with something like that, because those reviews have always been circling. Imagine this, you're sitting with a bureaucrat that all they're looking for is impact on industry right now, and you've been doing research.
So in the UK, we have this formal review of our research every 6 years, and we're asked to look at impact of our research. But the impact we're going to look at in the 2020 review is impact on research that's been going on since 2000. So that takes into account that research can take a long time to hit. So one of my colleagues who's been doing some research that's going into the C++ standard, but that takes time. It doesn't happen. He didn't have that immediately at the end of the research project. So I think, and it's not always, you don't know in advance what's going to have impact. But on the other hand, it's perverse to completely ignore problems that are out there in the world. I don't think it's right for us to say, we just know all the right things to do, we'll do them. It's important that we talk to people and people say, yes, solve that problem. You could solve this. It will be interesting, but it won't get us anywhere. But think about this. So it's important to do that. But even then, it might not necessarily get us where we want to go.
Yeah. One more question?
One more question?
Yeah, more questions.
Yeah. Multiple.
Hi, great discussion. Actually, I was one of those researchers during 2010 and 2012, and I even was our workshop chair in Tokyo in 2011.
Yes.
I actually got dropped out from the academic committee as a professor, and the one thing I would like to ask you is that more and more people who have PhD, especially those in Japan or elsewhere in the world, or the United States or in Europe, are going out of the research community to make their living, get more money, and get more higher living standard, because the industry are actually paying higher wages to those people. And under this difficulty, I'd like to ask you that how you are trying to get more people, more talented people, into the research community of functional programming in general, or Erlang, or even Elixir, or whatever related to the Beam community. Thank you.
Well, I think it's like with everything. It's if people like it, right? I'll step back a little bit. I think it's with any job, right? When we go somewhere, it's not only about, it's not the first thing that we look at, it's just salary, right? It's something exciting there. And if we have a project or interest from a student and the student is really excited about it, that's the way, they work with us, despite quite low income. And if they're hooked on it and that they get excited about the research, they want to get that into their lifestyle, and they stay. That's the.
But I would say it's not I wouldn't see this as a problem. I would see it as a sign of maturity. We've gone from a situation where we were training people to do research in functional programming, and they would either stay, maybe quite a few of them would stay in the research community having completed their PhD, and a few of them would go out into industry and go and work for companies like Microsoft, doing boring things and eventually telling people how to do functional programming, to one where they can go and employ their skills at an advanced level and are very highly sought after in large part of the community. So I see this as a success. As long as we're keeping enough people in the research community to keep things ticking over, then producing more PhDs, some of whom are working in industry, I think is actually very positive. It creates the academic industry connections that we were talking about earlier, and it feeds the next generation of research challenge to us.
Yeah, I think when I look at the kind of people that either go to industry or stay, it's not the salary. Natalia, I agree with you. It's not the salary that determines those things for those people. Those that stick on with research, they have a higher desire to explore that field and excel in the knowledge space, because excelling in the knowledge space is not the bulk of the work in an industry job. You accumulate knowledge, but it's not in the same way, and it's not with the same sort of purpose. So it's all about what you really want to do at the end of the day. I don't think money can solve that problem.
That would be nice.
It would be
have an
nice.
addition.
It would be nice, but you're taking my tax money, so we'll. So.
So I actually would like to disagree with, first of all, a bit with the question and with everything else that was said here.
This is the old Kostis.
Yes.
We
So,
good, right, okay, sleeves rolled up.
I work in academia, okay? For a number of years now, I've been working in academia. And I was fortunate enough to have a number of students over the years. I never saw my role in any of these students to direct them towards research or industry or whatever. So I don't see that this is my role. My role is while they are doing a PhD or some master thesis or even taking a course of mine, to make people interested in the thing that they are working at that time, and to try to have them produce good results, appreciate the difficulty of producing good results, having fun in the process. So I see that my role in doing this type of things, not to direct them towards getting a higher salary or a lower salary or doing interesting work or not doing interesting work. So I don't even see my role in forcing necessarily my students to take their PhD. You know who you are.
No, but Kostis, I actually think we're saying the same thing.
I think we are. You're,
Yeah,
you're agreeing with us, Kostis.
Yeah, but possibly. So
You're agreeing with us in a Greek way.
yeah,
That's fine.
So and I never saw my, I don't see or value my students depending on where they go and what they do after they graduate. I'm actually very proud of them, independently of what choices they make.
With or without
yes.
PhD, yes, okay.
You
know who you
are. I don't value success in terms of money or even excitement in projects that they do after they graduate.
I would just add a coda to this. I think it's perhaps happening more in Britain than in Sweden, but the big hitters are coming along, and Facebook and Google are hoovering out not so much young academics, but taking out. If you're an academic in AI who's any good, Google will have come along and offered you tons of money, and that can really distort the whole subdiscipline. Now, maybe people think AI is better in industry than in universities, but it's been happening a little bit in programming languages as well, and that can be unfortunate if you have an established academic community and they get moved into. And Facebook offer salaries that it's impossible to refuse because they're basically saying, carry on doing what you're doing, okay, with a Facebook spin to it, but earn n times.
N times.
Where n is an integer greater than
we will put the Facebook problems aside,
yes,
and wrap it up without going into political debates.
Oh yes, right.
Of those things. And would you join me in thanking the panel, Kostis, Kevin, Natalia, and Simon? Thank you very much.